Hello, my name is Leona Holloway and I am a researcher from Monash University in Melbourne, Australia, with a background in accessible formats production. And I'm really pleased to be with you today to talk about 3D printing for accessible education and mapping, a collaborative project in Australia and New Zealand. Thank you for joining me, so let's get started. Okay, so we're conducting a 3-year project looking at 3D printing for touch readers, and obviously it's going to be a bit hard to cram 3 years into 20 minutes. So what I'll do instead is give a really brief overview of the project goals and methods, and then we will drill down and look at just 3 key areas that hopefully are of interest to you. But along the way, I'll also point to a lot of other resources where you can find out more about our project. Okay. So the project title is Investigating 3D Printing for Access to Graphics by People Who Are Blind or Have Low Vision. And it is a 3-year project supported by the Australian Research Council. It's administered by Monash University, but it's a linkage project. So we're conducting it in partnership with our partners, linkage partners, the Roundtable on Information Access for People with Print Disabilities Inc., which is an umbrella organisation over Australia and New Zealand. Lots of different organisations are members, and in particular, the South Pacific Educators in Vision Impairment are assisting with this project through Roundtable. We also have partners with Department of Education and Training Victoria and their Accessible Formats production team, the Royal Institute for Deaf and Blind Children, Guide Dogs Victoria, and the Royal Society for the Blind in Adelaide. So our partners, we're really grateful to be working with them. They're fantastic, and they help with firstly guiding the project in terms of what we'll be looking at, as well as participating in evaluation of materials. Okay, our research goals are, the primary ones are to look at touch methods for accessing 3D printed models, which we'll talk about a little bit later. Also design recommendations. So how, in particular, if a 3D model is going to be used by a touch reader, what are some of the design considerations when you're creating that model? And supporting the uptake of 3D printing in the community. The research is being conducted in 2 main application areas. So the first one is education. So using 3D prints to support tactile literacy, and also in particular looking at STEM education, so technical materials. And the second area is orientation and mobility, so producing 3D printed maps to assist. Okay, so this slide has got a lot of text that you don't need to read right now. Basically, it just lists publications that we have. Our Inclusive Technologies group at Monash University has put out relating to 3D printing. So there's papers there, both laboratory studies and in the wild studies, looking at mapping, looking at use of 3D printing for art as well, and for travel, and also looking at interaction with 3D models. So please do look any of those up later if you're interested. All right, let's get stuck into the more interesting stuff. So key findings. What we'll look at today is the issue of what to print. We'll also look at 3D symbols, and then we'll look at principles for touch reading 3D printed models. Okay, so what should we be printing? This seems like an easy question. Basically, the first thing that we said is, well, anything that's inherently 3D and you can't get access to, then that is a good candidate for 3D printing. So if it was too big, for example, architecture, it's very difficult to feel what the roofs are like. unless you shrink it down. Anything that's too small, like a plant cell, for example, too rare, too expensive, dangerous, so can't be touched, or maybe it's conceptual, so things like mathematical 3D forms, and are not readily available or accessible in another form. So you can't go to the shop and buy a little tourist model. Well, you can go and buy a little tourist model of the Eiffel Tower. So that one, we would say just buy the tourist model rather than 3D printing. But there are other things where it is a lot more difficult to obtain a model any other way. Actually, it turns out that it's not that easy to know what to print. So there's still a lot of hesitancy amongst teachers in Australia and New Zealand about knowing what to ask for, or they're asking for things that are where there would be other options. So one of the things we've been doing is providing examples of things that can be 3D printed and would be a good idea. On screen, I've got a number of pictures. So the first one is a 3D printed model of the Arctic Circle with ice shelf from different years, which can be slotted on and off. And that was developed by the Department of Education in New South Wales. There is a set of tiles for the water cycle, so different components of the water cycle, and then arrows. And this is tactile and also in print, so that it can be used by blind and sighted students together. And because it's got different components, you can pull some out to make it appropriate for whatever year level you're working with. The next image is of the Sydney Opera House, 3D printed and as a tactile graphic. It's very difficult to understand that complex architecture, but using a 3D model makes it a lot easier, and also can help you to understand what the tactile graphic is meaning. The next example is a Braille swing cell. So it's got the 6 dots, it swings out, and then it's also little pegs that you can use to show the different formations of the Braille letters. So that's supporting Braille acquisition, but also understanding the 6-key entry. And that was produced by RADBC. The next example is a Perkins Braille finger guide. So it slots into a Perkins Braille and just helps the fingers stay on the right keys for beginner learners. And the last example I have there is a 2-story map of a school to help the student get oriented. So looking at all of those examples, I think that they really highlight the fact that 3D printing is not just suitable for supporting the curriculum in school, which is probably the first thing that we think of. It's also very useful to support tactile literacy, so whether that be obtaining Braille skills or just encouraging touch with more interactive and interesting things to touch. And thirdly, it's useful for accessibility tools for the classroom, so things like that Braille finger guide, and extra things like maps. So I think that even when we're providing all of those examples, you still need to have a good understanding of the curriculum. You need to have a good understanding of their student and their particular needs in the classroom. So those are things that the teachers and aides will know. But you also need to have a good understanding of just the practicalities of 3D printing design, so things like overhangs, etc., all of those sorts of things that the designers will have a better understanding of. So there does need to be quite a lot of, I think, conversation between teachers and designers in deciding what is practical and the best use of 3D printing. Okay, so turning now to 3D printed symbols for maps or for graphics as well. In our first comparative study, where we were looking at tactile graphics versus 3D prints, one of our findings was that the use of 3D printed symbols or icons for things like stairs or for benches, etc., they were a lot easier to understand as a 3D print than on the tactile graphic. And that then reduced the cognitive load. So it was easier to use a 3D model because it was easier to recognize what each of the symbols represented. And that finding was then backed up in another study that was done in the wild, where we had a lot of 3D symbols on a map and we had a key, but people were saying, well, I don't need to reference the key, and that makes it easier for me because it's so easy to recognize some of these symbols. Not all of them were successful. The other finding that we've had in terms of feedback from people in other studies is that having 3D printed icons, they're very distinct. It makes it easier to find a route of travel or to trace between one point and another, because it's easier to reference back and to find those two important points that you're going between. All of those things tell us that 3D printing, 3D printed symbols are really useful. But what 3D printed symbols should we be using is the next question. So we used a very iterative design process where we tried out lots and lots of things, did lots of touch testing, got feedback. And what we found was that there's kind of three things that you need for a good tactile symbol that's 3D. So it needs to be simple, it needs to be very distinct and individual, not similar to other things, and it also needs to have the main features on top where you will first touch. So for example, when we're looking at what's a good symbol for food, a lot of people suggested, well, you should have a plate with a knife and fork. But of course, once you reduce that down, you've just got a little disc with a couple of very small lines, and it's not distinct enough. So it couldn't be recognized. It could have been anything. What we came up with instead was a bowl with chopsticks, which was a much more distinct shape and much easier to recognize. That was a very successful symbol. But once we put noodles into that noodle bowl, those noodles added a lot of complexity. People became distracted trying to figure out what they were, feeling them, and it became a much less successful symbol. So simplicity is very important. The other example that I have on screen is a water tap. So we thought that that would be quite a distinct shape and would be useful to represent water. But what we found was that once it was fixed onto the map and you're reaching from the top, you just feel that top knob. But the distinct and important thing about the tap is the curved lip going down to the mouth of the tap, and that was not as easy to find. So it was a more difficult symbol to interpret. So the main features, the most distinctive features, need to be on the top of the symbol. Okay, and thirdly, looking at principles for touch reading 3D prints. Based on our observations of touch readers exploring our 3D prints, but also with reference to touch guidelines for tactile graphics, which there are a lot of and are very useful. And we also collaborated with some of our best touch readers who have been exposed to a lot of 3D prints to come up with some principles for touch reading 3D prints, so 5 general principles. These principles are published on the Roundtable website at printdisability.org. We've been producing our guidelines as we go in small sections. So this is one of the sections that is already available, and there will be more by the end of the project. So what I will do now is show a little video clip explaining those principles for touch reading.
Principle 1, know what to expect. Context is essential to understanding. First, give the title and a broad overview. For example, this is a model of the peak of Mount Everest. A braille label is given near the base, facing south. The model shows an area of approximately 25 kilometres along each side. Mount Everest is 8.8 kilometres above sea level. This model shows only the very top. Also talk about how the properties of the model differ from the real object. Most 3D prints are hollow and plastic with ridges on the side where the layers have been built up. Is the real object more soft, flexible, heavy, smooth? What is it made of? What is its scale? There's nothing new about Principle 1, except that anyone who's new to 3D printing needs to understand a bit about the production of 3D prints and how that affects how it feels. So, for example, anything with an overhang might feel rough underneath. Principle 2, gain an overview first. Use both hands with fingers spread to carefully feel the whole model. Smaller models can be rotated in the hands. Larger models should be explored systematically. While a systematic search can be conducted in the same way for every tactile graphic, the shape of a 3D print and any parts that are protruding can affect the way that it's explored by touch. So a more conscious effort might be needed to make sure that the whole model has been explored. Principle 3, use appropriate touch. Use the whole hand to understand the overall shape. Use curved fingers to explore details. A light touch may be needed to move over parts that stick out. Principle 4, use reference points for orientation and when exploring detail. The 3D print should first be given to the student in the correct orientation. Point out a prominent feature and its direction so that the correct orientation can be found again after it has been turned in the hands. As with tactile graphics, when exploring details, it is useful to keep one finger on a reference point while using the other hand to trace a line, pathway, or edge. Principle 5, explore the detail. Search the model for details not just on the outside, but also towards the base and on the sides of parts, feeling for holes or tunnels and for special markers. Things like the underside of a bridge can be easily missed. If these features are important, then they should be mentioned in the description that's given with the 3D print so that the touch reader can search for them.
Okay, so what next? 2020 was a fantastic year for requirements gathering, talking to people about what was needed, also for doing a lot of designing and 3D printing at home, produce a lot of materials, but it wasn't so good for getting touch feedback. So we're hoping that 2021 is the year when we'll be able to get a lot of materials out to people in field and get their feedback. In particular, we'll be testing textures, so 3D printed textures. We've got a set of textures that we use as standards for tactile graphics, but we'd like to have a standard set for 3D printing that we know are very distinct from one another. We'll also be looking at 3D printed street crossings, so materials that O&M instructors can use. And we'll also be looking at multi-part or interactive models for education and testing those in the classroom. The other thing that we'll be doing, as I said, we've been releasing guidelines in parts on the Roundtable website, and we'd like to have a complete set ready by the end of the year.
That's almost all from me for now, but first I would like to speak with you more about our project if it's of interest to you, and please do contact me or get involved. My email address is leona.holloway@monash.edu and my Twitter account is @leonaholloway20. You can follow our progress of the project on accessiblegraphics.org. We put monthly updates on there. Our guidelines are being published, as I said, on the Roundtable website. We've got 5 sets of guidelines already and there are more on the way. And you're most welcome to join the Australia and New Zealand Accessible Graphics Group Facebook group. We have a Facebook group for discussion of not just 3D prints, but all types of accessible graphics. Love to chat with you there. Also, the ANZAG group has a 3D printing group that meets monthly. We have about 30 members from Australia and New Zealand, mostly educators, talking at different stages of 3D printing, supporting each other in our adoption of 3D printing. And we do like to have monthly guests. So if you're from overseas and would like to join us, please let me know and we'd love to have you come along. And finally, there's another Facebook group called Blind and Low Vision 3D Printing Group, where we discuss 3D printing for touch readers, but we also have a lot of discussion about how we can make the process of 3D design and production accessible. Okay, thank you very much for your time today, and I look forward to your questions.